Today we will discuss about inverse Laplace transform of derivatives and integrals. First of all, we will discuss about Laplace transform of derivatives. If inverse Laplace transform of fp is fx, then inverse Laplace transform nth derivative of fp is 1 minus 1 raised to power n x raised to power n fx, where n is 1, 2, 3 up to infinity. We know that the Laplace transform of x raised to power n fx is equal to minus 1 raised to power n dn dpn fp, or we can write it as minus 1 raised to power n fn p, nth derivative of p. Taking inverse Laplace transform both sides, inverse Laplace transform of this one minus 1 inverse Laplace transform of minus 1 raised to power n f n p is equal to x raised to power n fx, or f n p is equal to minus 1 raised to power n x n raised to power n fx, where n is equal to 1, 2, 3 up to this one. This is the inverse Laplace transform of derivatives, nth derivative. We can put n is equal to 1, then it will become minus x fx. If we put n is equal to 2, then it will become x square fx, x cube fx, and so on. Now, inverse Laplace transform of integrals. If inverse Laplace transform of f is fx, then inverse Laplace transform of p integral p to infinity f p dp is equal to fx upon x. We know that Laplace transform of fx upon x, division by x, fx is divided by x, is given as p to integral p to infinity fp dp. Taking inverse Laplace transform both sides, inverse Laplace transform of integral p to infinity fp dp will be equal to fx upon x. Now we will discuss about Laplace transform of a function when it is multiplied, inverse Laplace transform of a function when it is multiplied by powers of p or division of p. Multiplication by powers of p. If inverse Laplace transform of fp is fx and f0 is equal to 0, the function at x is equal to 0 is 0, then inverse Laplace transform of p fp will be equal to f dash x. We know that Laplace transform of derivatives or first derivative of fx is p Laplace transform of fx minus f0. Here f0 is equal to 0, therefore Laplace transform of f dash x will be equal to p Laplace transform of fx, or Laplace transform of f dash x is equal to p fp. Taking inverse Laplace transform both sides, f dash x will be equal to inverse Laplace transform of p fp. Now we will discuss about the division by powers of p, when the function is divided by powers of p. If inverse Laplace transform of fp is equal to fx, then inverse Laplace transform of fp upon p will be equal to integral 0 to x fu du, provided limit x tends to infinity, fx upon x exists. This function exists. Let gx is equal to 0 to infinity, taking this integral at gx. Gx is equal to 0 to integral 0 to x fu du. Differentiating both sides with respect to x, g dash x is equal to fx, g0 is equal to 0. When both the limits of integral are 0, then it will become 0. But Laplace transform of g dash x is given as p Laplace transform of gx minus g0. Here g0 is equal to 0. Or Laplace transform of g dash x is equal to p Laplace transform of gx. Or Laplace transform of gx will be equal to Laplace transform of f dash x will be equal to fp will be equal to f p Laplace transform of gx, or Laplace transform of gx is equal to fp upon p. Here g dash x is equal to fx. Therefore, we put g dash x is equal to fx. Laplace transform of fx is given as fp, and it will become fp is equal to p Laplace transform of gx, or Laplace transform of gx is equal to fp upon p. Put the value of gx is equal to integral 0 to x fu du will be equal to fp upon p. Taking inverse Laplace transform both sides, inverse Laplace transform of fp upon p will be equal to integral 0 to x fu du. Now we discuss an example. Find the inverse Laplace transform of p upon p square plus a square whole square. We know that differentiation, a first derivative of 1 upon p square plus a square with respect to p will be equal to minus 2p upon p square plus a square whole square. Or we can write p upon p square plus a square whole square, which is this one, fp is equal to minus half d upon dp 1 upon p square plus a square. Now inverse Laplace transform of p upon p square plus a square whole square will be equal to inverse Laplace transform of minus half first derivative of 1 upon p square plus a square will be equal to minus half inverse Laplace transform of first derivative of 1 upon p square plus a square. Inverse Laplace transform of derivatives is given as minus 1 raised to power 1 x raised to power 1 inverse Laplace transform of 1 upon p square plus a square, and the inverse Laplace transform of 1 upon p square upon a square will be given as sin ax upon a. Inverse Laplace transform of 1 upon p square plus a square will be equal to sin ax upon a. The next example, find the Laplace transform of inverse Laplace transform of 1 upon p cube into p square plus 1. This is the example of division by p. We know that inverse Laplace transform of 1 upon p square plus 1 will be equal to sin x. By division property, we know that inverse Laplace transform of 1 upon p into p square plus 1 will be equal to 0 to x sin u du. Integration 0 to x sin u du. Integrating this one, this becomes cos u. Put the limits of u from 0 to x, it will become 1 minus cos x. Again, inverse Laplace transform of 1 upon p square into p plus 1. Again integrating this one with respect to 0 to x, 1 minus cos u du. The integration of this one will be x minus sin x. Again integrating with respect to 0 to x. Again, an inverse Laplace transform of 1 upon p cube p square plus 1 will be equal to integration of this one 0 to x u minus sin u du, or integrating this one x and putting the limit from 0 to x square by 2 plus cos x minus 1. Next example. Prove that inverse Laplace transform of log 1 plus 1 upon p square will be equal to 2 upon x 1 minus cos x. Hence, evaluate inverse Laplace transform of 1 upon p log 1 plus 1 upon p square. Let fp is equal to log 1 plus 1 upon p square, or we can write this one as is equal to log 1 plus p square upon p square, or minus log p square upon 1 plus p square is equal to log minus log p square minus log 1 plus p square. This may be written as 2 log p plus log p square plus 1. Differentiating with respect to p, f dash p will be equal to minus 2 1 upon p minus p upon p square plus 1. 2 common. Taking inverse Laplace transform, both sides, inverse Laplace transform of f dash p will be equal to minus 2 inverse Laplace transform of 1 upon p plus 2 inverse Laplace transform of p upon p square plus 1 minus 2 inverse Laplace transform of 1 upon p will be 1 plus 2 inverse Laplace transform of p upon p square plus 1 will be cos x. Therefore, minus 2 common, 1 minus cos x. Inverse Laplace transform of d upon dp fp will be equal to minus x inverse Laplace transform of fp minus 1 raised to power n x raised to power 1 inverse Laplace transform of fp is equal to minus 2 1 minus cos x, or this will cancel. Inverse Laplace transform of fp will be equal to log 1 plus 1 upon p square is equal to 2 upon x 1 minus cos x. By division property, when we divide this one by p, inverse Laplace transform of 1 upon p log 1 plus 1 upon p square will be equal to integration of this function from 0 to x 1 minus cos u upon u and du. Hence proved.